Hi future doctors, welcome to the next class. We were discussing about vertical circular motion. So we will see finally how they may give. So object is at A. If it is rotating in clockwise or anti-clockwise direction, so then velocity at this point A. Already we discussed root 5g r. Tension at A. TA is going to be how much we got? 6 mg. Next time. Velocity at B, VB, we got root 3GR. Tension at B, we got 3 mg. Next time. At C, at topmost point, VC is equal to root GR. TC is going to become 0. So again, at the same position, horizontal position at B and C, both are going to be same. Therefore, VC is equal to root 3GR. We got like this. Correct? Now, in previous class we discussed if it is n mg, it is going to be n minus 1 mg. If it is ngr, then it is n plus 1 mg. So like this they are going to give. So at one position we discussed in previous class. Now we will see velocity at A is going to be root ngr. Then what is the tension at A? Tension at A is n plus 1 mg. How they will give means root 9gr at the time 10 mg. Let us assume. So now n is going to be here 5. Same n if you consider here. Now velocity at B. Here you got 3. If it is n, 5. 5 minus 2. Therefore, here you will get n minus 2 G R. Tension at B. This is also n minus 2 mg. Here what we are writing? Same thing we will write. So in previous class we discussed this is n plus 1 like this. This is n. This is n minus n like this we discussed. Now here n I am giving. In all the cases we are discussing with same n. Isn't it? Now here what will happen? Here 1 is there. Here 1 is there. Here n is going to be 5 means. If you want to get 1 means, what should be VC in terms of n? So 5 minus 4, that is going to be n minus 4 GR. Isn't it? So n minus 4 GR is nothing but velocity at topmost point. Now, just we will see just one simple example. Velocity at A is going to be root 9 GR they gave velocity at A at bottommost point. Then what is the tension at A? PA is going to be 9 plus 1, 10 mg. Now what is the velocity at B? Velocity at B is nothing but, so n minus 2. What is n value here? 9. So 9 minus 2, that is going to be 7 gr under root. Now what is the velocity at C? N minus 4. Here n is 9. Therefore 9 minus 4. 5 gr. So to complete vertical circular path, what should be the velocity at the bottom? So that is going to be root 5 gr. If it is less than, it will not complete. It will be going somewhere and it will be coming backwards. Isn't it? In problems, we will discuss very important one, this one. To complete vertical circular path, what is the velocity at bottommost point means root 5 gr. In vertical circular path, object is suspended by a string. In tube, they will say. In tube, whenever they are giving, here root 4 gr will be coming. So in problems, we will discuss those. So this is about vertical circular motion in a simple way to remember, isn't it? So sometimes here n plus 1 we have taken. So this one is nmg they will give. TA is going to be nmg. In place of n, 6 is there. Now here what is VA we should write? N minus 1 mg. Correct? So with this we are going n minus 1. At that time here 3 is there. So n. Here we wrote n minus 2. So in place of 6, if you want to get 3, what we have to write? 6 minus 3, that is nothing but n minus 3. When, if you are taking TA as NMG. But previously we discussed VA as MGR. Like this, we got this one. So any one you can remember, definitely you will get remaining. Next, acceleration of rolling body. So acceleration of rolling body. So whenever object is getting rolling, let us assume you can take a ring like this, you can wound one wire like this. Whenever you are wounding wire, after taking last end of that wire or thread, you can leave this. Whenever you are leaving, it will be rotating and rolling, isn't it? Linear motion. So it will be rolling and going. If you drop means it will go directly without rolling. Then this is moving. But whenever you are making windings, it will be rolling like this and it will be going downwards like this. At the time, how we will discuss this. So already we came to know. So this is nothing but rope or thread. So within this string, what will be developed? Tensional force. How it is going to be moving means downwards. Where external force is going to act means at center. Now it is moving downwards with acceleration A. So in laws of motion we discussed, whenever it is moving downwards, net force, how we will write? Mg minus T. So net force Ma equal to Mg minus T. Then T is going to be mg minus ma. So we discussed so many times. Object is moving downwards means mg minus ma. Upwards means mg plus ma. Correct? Now it is rotating. Rotating means torque is also going to be applied. How to get torque from this means? So this is nothing but perpendicular distance. This is nothing but force. Torque tau is equal to force into perpendicular distance. P into R. So, according to torque, we can write I alpha. I is moment of inertia. Now, what is the relation between linear acceleration and angular acceleration? This is angular acceleration. So, that relation is going to be A is equal to R alpha. Alpha is going to be A by R. Can we write? Then T into R is equal to I into A by R. Then T is equal to IA by R square. Correct? So IA by R square. Now what is I means here? Moment of inertia of rolling disk. I am going to write M K square into A by R square. So moment of inertia of rolling ring. In rolling body we wrote mk square na, like that. So I into A by R square, A is acceleration, T is tensional force. Now equate these two. Then what we are going to get? Now see, P equal to mg minus ma. T equal to m k square A by R square. So send this one that side. Mg equal to ma plus mk square A by R square. So what will be cancelled? M will be cancelled. Then G is equal to A, if it is common, 1 plus K square by R square. Then what is A? G by 1 plus K square by R square. Very, very important equation. This one we got so many times. This is acceleration of the rolling body downwards. So, if ring is only moving downwards, at that time acceleration is G. If ring is rolling and moving downwards, then acceleration is going to be G by 1 plus K square by R square. So these formulas you got so many times for linear motion and rolling motion. So object is moving downwards, which is having angle of inclination theta, height h. Then what is the velocity at this bottom? V is equal to root 2gl sine theta, otherwise root 2g h. If it is rolling, an object is going rolling. At the time, what we got velocity? Root 2gh by 1 plus k square by r square. Like that, acceleration, what you got here? Acceleration is g sine theta. If it is moving, if it is rolling, g sine theta by 1 plus k square by r square. How much time it is taking? Time taking is root 2l by g sine theta if it is moving. If it is rolling, what is the time taken? Root 2l by g sine theta into 1 plus k square by r square. So, this 1 plus k square by r square term is coming if you observe in each and every equation. Like this, if it is rolling means moving, the acceleration is g. If it is rolling and moving, 1 plus k square by r square. If you want this equation in terms of I, in place of mk square, we will write I. So, that equation how it will be coming means mg minus ma is going to be equal to ia by r square. Correct? ia by r square. You can send that one this side. So, mg equal to ma plus ia by r square. Now, what is common here? Acceleration is common, m plus I by r square equal to mg. Then a is equal to mg by m plus I by r square. So, for ring, k value is going to be r. For disc, k value is going to be r by, means r by root 2, k square will be coming 1 by 2. Like that, if you wound wire or wind wire, what will be coming on the sphere? Hollow sphere, solid sphere. For that moment of inertia, 2 by 3, 2 by 5. Like that we are going to take. This is the acceleration of rolling body which is coming downwards. Whenever they are giving any object by applying force, the force is applied like this, then torque tau is equal to force into distance, and that should be equal to I alpha. If they are applying force at center, then F equal to m a we are going to write, isn't it? With acceleration if it is going to be moving. So, if you are applying force here, it will be rolling. Whenever it is rolling, we have to take like this, torque tau is equal to force into distance. Sometimes they will give frictional force backwards. At the time, applied force minus frictional force will take resultant force. So, like this we are going to apply the equations. So, this is for rolling body. So, once you understood, then definitely we can apply very easily whenever we are solving the problems. So, this is about rotational dynamics. Thank you.